Hey guys, I'm gonna have to be really quiet here because I'm just outside the courtroom, so hopefully you guys can hear me okay. In this video, I'm gonna go briefly through what may be important to put on your note card and what were the basic things that you kind of need to know. So let's go through some of the key ideas here. Okay, so one key idea is potential energy. And that is the energy of position. We're going to measure it just like we measure all types of energy in this class in joules. And the equation for that is P is equal to mass times gravity times height. If you're really solid on this stuff and the understanding, I would just put this on my note card. Anything else is always extra and would be helpful if you're struggling. Kinetic energy is next, and it is the energy of motion. Like all energies, we measure it in joules, and that equation is K is equal to mv squared divided by 2. If I was really solid on this, I would only put this on my note card. Mechanical energy is the potential energy and then a kinetic energy added together. Again, it's measured in joules, and it kind of defines its own equation. Work is going to add or remove mechanical energy from a system. It's measured in joules, just like the other energies. The equation that we use for it is work is equal to force times distance times the cosine of the angle between them. So I put that on my note card. Oh, I would have put this on my note card too. Okay, force was something we covered a lot before, but in case you needed it to kind of keep track of things, force is a push or pull. It's measured in newtons, and we use the equation F is equal to ma. We have not had to use that equation very often in this section. Okay, the law of conservation of energy just states that energy cannot be created or destroyed. So if you have a ball rolling along the ground and it comes to a stop, you may feel like it lost energy, but actually that energy didn't go anywhere. It went off and became thermal energy and sound